All right, let's talk a little bit more about MIDI. Get away from sound for a second and talk about those instructions. So with MIDI hardware, obviously you hit a key, you get a note, and a little bit more. All MIDI hardware transmits MIDI data in a number of ways, but not always all of them. Typically, you're going to have in and out. In receives MIDI messages. It's pretty standard on a synth module. Out transmits MIDI messages, and this is necessary for a MIDI controller to send MIDI data to your DAW so you can convert that into sound with a virtual instrument. On some older things, but it's kind of depreciated now, you'll see MIDI through. This passes on an exact copy of the MIDI data that's received in the import, but it's different from out in that it is an exact copy. Out can pass MIDI in data, but it changes it usually. This is cool because it does let you daisy chain multiple modules together from one MIDI output on your controller or your computer. So you can send different things and just make sure that your modules are receiving on different channels, and it will only take the stuff that's on the channel that it's configured to. Very useful. Let's talk about MIDI controllers. These are the devices that only send MIDI data. They don't make any sound in and of themselves for the most part. Typically, you're familiar with the keyboard style. Looks like a piano, feels like a piano, kind of. Might have pedals, but doesn't make any sound unless you plug it into a program. There's also pads, or MPCs, MIDI percussion controllers. There are drum sets that use MIDI entirely, like the Roland series. Electronic wind instruments, or EWIs, which can be played using standard wind fingerings. Or there are things that have more interesting layouts, like a hex grid, or radio antennas, stuff like that. Here's a keyboard controller that should look pretty familiar. This is the Arturia Keylab 49 Essential, which we have in the lab, complete with the light up on all of the LEDs. This is an MPC controller. This is an Akai MPC Studio. You'll note that it's got 16 pads arranged in a 4x4 layout. Then you also have additional controls that you can use to change the sound if you're using their built-in software or a different software program that's compatible with that layout. Then we've got the drum controller, the Roland V drums. Instead of having actual drums, you have heads that actually feel pretty good, the snare in particular, and pedals that correspond to things like the hi-hat or the kick drum. The cymbals are made out of a very, very dense rubberized plastic. All of these have cords coming into them that go into the sound module on the left, but this photo does not have those displayed. And the EWI. This is just basically set out to use a clarinet or saxophone fingering layout. It's got the keys, there are thumb keys on the back, and there is a USB input on the back as well, and it's also got a chin strap. MIDI hardware has a very standardized set of connections for ins and outs. Typically, you have the 5-pin DIN connector, which is shown below, and the 5-pin DIN cable, or you can use USB. Nowadays, some devices can also be wireless over Bluetooth. MIDI through, by and large, is exclusively a 5-pin DIN cable. I have yet to see a USB MIDI through. If you have an example of it, please let me know. So, sound modules. In and of itself, MIDI, again, is just instructions. It is not sound. It doesn't create sound. It just tells a smarter device what to do. It's a communications protocol. The modules take this information and then convert that into sound. And there are three major types of modules. There is a synthesizer, there is the sampler, And there's hybrid modules that will have some aspects of synth and some aspects of sampling built in. All of these can come with built-in attached keyboards, like a keyboard synthesizer like the Arturia Micro Brute, or they can just be desktop modules. They're still popular, but they're nowhere near as popular as they were in the 90s and the early 2000s. And this is primarily due to the fact that nowadays there's just a lot of really good software out there. There's a lot of soft synths and sample libraries on a computer. They don't take up rack space, and they generally sound really good. But some of the really, really interesting sound modules are still available, and you can still buy some really good ones. Unfortunately, they are now very expensive. But let's take a look at a module. This is the Moog Mother 32 semi-modular analog synthesizer. You can see in the lower left that it has a 5-pin MIDI in DIN port. It also has a built-in rubber keyboard that gives you C to C in an octave, although you can transpose that up and down by steps, whatever. Then you have a bunch of knobs that control the various parameters of the synthesizer. You have a patch bay that allows you to reroute those signals so that you can have, say, your envelope controlling your filter and your frequency modulation, and maybe your resonance is being controlled by a different LFO from the one that you're selecting. You might use the triangle LFO to modulate pulse width and use a square LFO to modulate your resonance. It's very cool. Eventually, all of that signal is passed out of a 1/4-inch jack on the back of the unit as audio. One of the cooler things that's out there now, recent innovation from the last decade, is MIDI polyphonic expression, or MPE controllers. MPE is an extension of the MIDI specification and is now actually part of the MIDI 2.0 spec officially. That was created by a coalition of people including Geert Bevin, Lippold Haken, Keith McMillan, Roger Lynn, Apple, Madrona Labs, Moog Music, and Rolly. And this is super cool. It uses a dedicated MIDI channel as a global channel, and also uses dedicated channels for every single note you play, which means that you can add vibrato to individual notes of a chord. You can hold the root and the fifth static and vibrate the third, and only the third. You could bend the pitch of an individual note in a chord, take that third from major, and then bend its pitch down and make it minor, but the root and the fifth stay the same. If you were to try to do that with regular MIDI, you would notice very, very quickly that all 3 notes would pitch bend down the same way. It gives you things like independent control over filter cutoffs or resonance, again, for each individual note. This is more or less standard now that you'll have either filter resonance or filter cutoff in MPE. And the coolest thing is that you can gliss in multiple directions at the same time, so you too can recreate the THX sound effect. It results in incredibly detailed, nuanced, and expressive performances when you pair it up with a synthesizer or sample library that supports MPE, like Rolly's Equator, UVI's Falcon, East West's sample libraries. But it is definitely not cheap. The cheapest one that I've found thus far is the Sensel Morph without any control overlays. It's $250, and then it expands to about $1,500 for the Linstrument, and the 88 key version of the Rolly Seaboard is $9,000. But here's what they look like. This is the Rolly Seaboard Rise 25. Instead of having keys, you have a squishy material they call key waves that you can kind of press your fingers into, and it's almost like a cat pawing at you, in that you're just going into the material. But you can pitch bend all the way across. You can move up and down on the keys to control filter. It's very cool. Next up is the Roger Linn design Linstrument. It's a 200 cell grid, and each row is then ascending. The next row up is a fourth above, so it's tuned similar to an electric bass. This is a really cool controller for string players and one of my personal favorites. But again, you can pitch bend any note all the way up and down by upwards of 2 octaves, 25 semitones, either direction, independent from all the others. Plus you have pressure and filter cutoff, and everything about it can be remapped. It's very cool. Last but not least is the Sensel Morph, which is a gigantic array of pressure sensors on the pad at the bottom of the stack. And then you change the function of it by putting on different overlays that use magnets and different RFID chips to change the functionality of it. So the yellow one is a drum overlay, then a piano keyboard overlay, and then the MPC pad overlay. Very nice stuff. Very cool. Again, though, you have to have a program that is capable of making use of MPE data. So MIDI messages. What's going on in there? Let's dissect the data of a MIDI message. Before we get to messages, let's talk about the channels. You have 16 channels on a single 5-pin DIN or USB cable. Channel 10, as per the general MIDI spec that everybody agreed upon, is reserved specifically for drums, nothing else. Although you can override it if you really want to. Most modern modules or synths on the computer can handle multiple channels at once, making it possible to play 2 or more timbres simultaneously. You also have what's called omni mode on a lot of soft synths in particular, where it will receive data on all channels simultaneously. So you can have one keyboard playing and sending all of its data on channel 1 and one doing the same thing on 16, and 2 people can play it at the same time, and you'll get different parts being played. It's very cool. The channel messages are the most common type. These are what are coming down through the channels. You have note messages, which tell it what note to play, and generally what velocity and when the note is off. You have expressive messages or control messages, which tell the module what to do, to open a filter, to change the dynamics, to maybe do something with an LFO or the mod wheel or pitch bend. Then you have program messages. These are very, very different depending on what they're going to. They can tell it to switch preset. They could tell it to switch banks of presets. They could access system-specific functions. We're not really going to get into those that much. The system messages are even less common, though. You have things that would come through the device and control things like the time code, the playback state, if you're going back a measure, if you're going forward a measure, if you're stopping, starting, recording, or system-specific messages. And again, those can get very, very different very, very quickly. With the channel messages, we have note on and note off as the most important. This just flat out tells what key you pressed and then what pitch should be played. These key numbers are paired with a velocity. Some programs and key controllers have dedicated MIDI off. Some will just send the exact same key number with a velocity of 0 for off. The key range for MIDI is 0 to 127. This is just an arbitrary limit that was imposed based on the technology of the early 80s when they developed it. Note 60 is middle C. Note 69 is A440. These are the 2 you need to remember. Everything else you can just add or subtract in order to get to. An 88 key piano, the range is MIDI note 21 at the bottom and MIDI note 108 at the very top. So don't exceed that, or you're going to start getting into that supersonic or subsonic frequencies that humans aren't going to be able to hear too well. Velocity represents how fast the key is hit. Typically, but not always, this is a representation of volume on keyboard controllers. If you load up a piano sample and hit a key really, really super lightly, you're going to get a low volume. If you hammer it, you're going to get a high volume. That's not always the case, but 9 times out of 10 it is. So why are note on and note off two separate messages? Well, the big thing is sustain. When you hit the key, you send the note on message. When you release the key, you send the note off message or the velocity 0 message. This lets you hold non-percussive sounds like synths or winds or strings, instruments that can sustain, as opposed to a piano where you hit the key, you might be holding the pedal, but eventually it's going to die away on its own. In order to turn off a note, you do need to send that key number of the playing key and a velocity of 0. If you don't do that, it will stay on and you will get stuck notes. Typically on most synths, there's a panic button that is there specifically for this situation. This is definitely something you're going to want to remember, and we will review in MUS 4711. Believe me. Another thing to take a look at is expressive messages. These are commonly referred to as control changes, or CC numbers. These are typically mapped to a knob or fader on the controller. They transmit the channel, the control number, and the value. And again, as with anything in MIDI, the values are 0 to 127. So, why would we want this? Why would we have these extra knobs on top of a keyboard? It's a keyboard. We want to press key and get a sound. Well, because in every DAW, you can map those control values to different functions. So you could map out, say, panning to knob number 1, or resonance to knob number 2. Or if you've got faders, you could set that up to control the faders in your mixer, in your DAW. There are a number of standardized CC messages, though. There's a nice chart on page 196 in the book. But the ones you really need to be aware of are CC1, which is the modulation wheel, 7, which is volume, not velocity, but actual volume, 10, which is pan, 11, which is expression, 64, this is the big one, that is the sustain pedal. CC64, 0 to 63 is off, 64 to 127 is on. You will use that insanely a lot of times, especially in later classes. Then there is CC74, that is the filter cutoff frequency. Again, the control value determines the value of the parameter it's mapped to in software. So there's going to be different effects depending on what you map it to, but it's going to scale that 0 to 127 value that it's receiving to whatever you map to in software. There's also a lot more in the MIDI spec. I've provided a link for that if you really want to go through that, but it's a pretty long read. A little bit more on the expressive messages. The mod wheel, or the modulation joystick that some manufacturers have, the effect is different depending on the sound module, but it typically controls the low frequency oscillator, the filter, or some other modulation device. Pitch bend is the only thing on MIDI that is not going to use a 0 to 127 schematic. It is, in fact, two numbers. It's a coarse and fine blend that combine to create a really, really, really large range from negative 8192 to positive 8191, which gives you a very highly accurate detuning of a pitch. Now, how far it detunes depends on the module, but it's usually something that you can adjust, and it typically is a range of plus or minus 2 semitones that can go upwards of plus or minus 48 semitones, which is 4 octaves or more. Finally, we have aftertouch and pressure. This adds a pressure value after the key has been pressed that's commonly used for things like opening or closing a filter, adjusting resonance, or tweaking the volume after the initial velocity has created the initial hit. Following up on that, you have polyphonic key pressure, which is a little bit rarer, but common in MPE, where each key sends its own separate pressure value. Very, very fun stuff. Finally, one big thing to be aware of is the difference between continuous and switch controllers. Continuous controllers have a value that ranges from 0 to 127 to provide different degrees of whatever parameter you're mapping it to. So things like the mod wheel, the volume, the pan, the filter cutoff, you can slowly increment from 0 all the way to 127 and get different effects that are going to be just stepped, smoothed variants of that control. Switch controllers, however, are either 100% on or 100% off. They're on and they're off, and that's it. So, for example, 0 to 63 on a switch controller is off, 64 to 127 is on. It is always like this on a sustain pedal, which is, again, CC64. And this is really useful because these allow you to use these specific controllers as on and off switches. You just need to take a look and say, okay, this is off, this is on. I'm going to have it do one thing if it's off and one thing if it's on, and never the two shall meet. And you don't have to worry about morphine values or what if it's this range versus this range. It's either one or the other.